Welcome to the Titus Timeout podcast. I'm Matthew McLaurin. In this episode, we will address condensation prevention strategies for systems that are designed to decouple sensible and latent cooling, like chill beams and series fan boxes with sensible cooling coils. I want to start by pointing out that this is not as big of a concern as it might seem. In a traditional all-air system, the supply air temperature is 55 degrees. As the air flows through the supply grills or diffusers, the surface temperature of those grills or diffusers will be around 58 degrees. Common chill water supply temperatures for decoupled sensible systems are around 57 to 58 degrees, which is the same as the surface temperature of a diffuser in an all-air system. So for either type of system, there is no risk of condensation as long as the volume of primary air being supplied is sufficient to maintain room humidity levels. In a traditional system, the amount of latent cooling is directly tied to the amount of sensible cooling provided. When there is a call for cooling, the VAV box will open to supply more airflow to the space, providing both increased sensible and latent cooling. When this occurs, the humidity levels in the space will drop as well. If the need for increased cooling was a sensible load like solar or equipment loads, the latent load would remain constant. And once space temperature is brought back within set point and airflow drops back to minimum levels, the humidity would remain at that new lower level. The end result is that most spaces served by an all-air system don't have a concern with condensation prevention. With a decoupled system, we want to minimize the primary airflow as much as possible and let the sensible coils provide the majority of cooling to the space. In this case, when there is a call for cooling, the chilled water valve opens, providing increased sensible cooling to the space. In this case, the primary airflow remains the same, and humidity levels also remain constant. Because this type of system behaves differently, there needs to be a strategy in place for addressing variable humidity loads, since there is not the unnecessary additional latent capacity found in an all-air system. The most straightforward approach is to shut off water to the coils and the sensible cooling products when the dew point temperature gets within a degree or two of the supply water temperature. The downside to this approach is that you lose your primary source for sensible cooling until the humidity levels are brought back down. Alternatively, there are two approaches that can be used to keep all or part of your sensible cooling capacity in place. The first is to use a mixing valve on the supply water system. When the dew point in the space begins to rise, the supply water temperature is increased as well to maintain an offset from the room dew point. Once dew point returns to its design condition, the supply water temperature is lowered as well. The second option is to use the primary air system to address the increased humidity. As dew point temperature rises, the primary air valve opens, increasing airflow to the space, which will provide increased latent cooling as discussed previously. This will lower the humidity level in the space back to the design set point, providing condensation-free operation. With simple strategies in place like these, condensation can be easily avoided in decoupled systems. For more information on sensible cooling systems like chill beams or our sensible cooling fan-powered units, visit our YouTube channel for access to previous webinars and podcasts on the topics. Don't forget to subscribe to our YouTube channel while you're there, and thanks for taking the time out with us.